Welcome to the Deep Dive. We are a shortcut to understanding what's really happening in tech. And today, wow, we are tearing into Anthropic's Claude Sonnet 4.5 release.
Yeah, looking at everything we've gathered, this isn't just, another small step. No, not at all. It feels like a really calculated move, architecturally, strategically. They're aiming straight for autonomous software engineering, exactly. They're positioning Sonnet 4.5 less like a better copilot and more like the engine, the core, for agents that actually work on their own. So our mission today is pretty clear. We need to get under the hood, deconstruct the tech choices here, look at those performance numbers, which are frankly staggering, and then figure out, okay, what does this actually mean for your workflow, for your company strategy, like right now? Okay, let's unpack this then. Where do we start? I think it has to be the basic architecture, right?
Yeah.
Because that really sets the stage for everything else. The speed versus complexity thing. Yeah, why did they build it this way? This kind of dual purpose system.
Well, what's really interesting, I think, is that Anthropic clearly recognized this fundamental trade-off you always get with these huge models. You could have really deep, thoughtful analysis, which takes time, it's high latency, or you get super quick, low latency execution, getting both at peak performance. That's tough. So they tackled it with what they're calling the hybrid reasoning engine.
Hybrid engine, okay.
Yeah. And it's not just like flipping a switch. It's a deliberate design choice about how computation's allocated. So for most tasks, the default standard mode. Think it like everyday chat, simple data stuff. The request often gets routed dynamically through a smaller, faster, lower compute part of the model. That keeps the speed up and, importantly, the cost down.
Right, fast and cheap for the common stuff.
Exactly. But then, if you've got something complex like designing a system or some really gnarly coding, you can specifically activate the extended thinking mode. There's an API parameter for it. And that reserves the full power, the full complexity of the model for your request. Sure, it uses more compute, takes a bit longer, but here's the kicker. It generates a visible chain of thought, a Chorus-y reasoning path.
Ah, so you can see how it got the answer.
Precisely. And that's huge for transparency, right? It stops being this complete black box. You can actually audit its decision process, debug it. It feels much more like a collaborator.
Okay, that dual architecture makes a lot of sense. It serves two different needs, almost two different markets, fast and cheap or slower but transparent.
Yeah.
And looking at the specs for actually using this thing in production, they seem to have tackled two other big pain points: how old the data is and context length. The knowledge cut off July 2025. That's really recent.
Yeah, that is pretty fresh.
It means, less immediate pressure to set up complex array systems just to handle current frameworks or events.
Right. Retrieval augmented generation becomes less critical for just basic recency.
But then we hit the big number, the 1 million token context window. That's in preview beta, though.
Yeah.
The general availability, the GA version, is 200,000 tokens. So that 1M number gets the headlines, but if it's not GA, are they just, using it for hype? Is it vaporware at this point?
That is the absolute critical question you have to ask with these big announcements. And to their credit, Anthropic gave us the answer themselves with a pretty significant warning. They were actually quite open about it. They said, and I'm quoting roughly here, that the 1 million token setup was implicated in our recent inference issues.
Inference issues. Okay, that sounds like instability.
That's exactly what it sounds like. And for anyone building systems, that's gold, that information. It means, look, the potential for massive context is there, theoretically. But the reliable, stable limit, the one you can bet your production workload on, that's still the 200K GA window. You absolutely cannot deploy anything critical on that 1M setting right now without doing some serious internal stress testing.
Got it. So 1M is the future goal, 200K is the present reality for stable deployment.
Exactly. The stability just isn't guaranteed yet at that scale, no matter how impressive the number sounds.
Okay, so if 200K context is the stable reality, then performance within that context becomes the main battleground. And this is where Anthropic is claiming, quantitative dominance, state-of-the-art results, they say, especially in two key areas for these agentic systems: coding ability and just general computer interaction.
That's right.
So on SWE-bench, that's the one that measures fixing real code bugs from GitHub, they hit 77.2% state-of-the-art. But the number that really caught my eye was their high compute score, 82.0%. They say this simulates a fully autonomous agent, and competitors like GPT-5 Codex are around 74.5%. That's a noticeable gap. What are they doing differently technically to get that boost?
Yeah, that 82% is interesting. It seems like they're really leaning into this idea of autonomous quality assurance, like mimicking how a careful human engineer might work. That high compute score isn't just one shot. It involves parallel sampling and rejection testing,
Mhm.
meaning the model doesn't just spit out one answer. It generates several potential fixes at the same time.
Mhm.
Then it evaluates those potential fixes against tests, maybe internal checks,
Yeah.
and picks the best one before it actually makes the change.
So it's like generating multiple drafts and self-critiquing.
Kind of, yeah. It's like it's exploring the solution space more broadly, almost brute forcing it, but intelligently before committing.
Yeah.
It's definitely a step beyond just sequential single answer generation.
Okay, that makes sense. And coding is one piece. What about the other half? The agentic capability.
Right. OS world. That benchmark tests how well the model can actually do things on a computer.
Mhm.
Navigate files, use a browser, interact with apps, basically the core skills an agent needs.
And the score there.
A new record, 61.4%. But what's really striking isn't just the number, it's the speed of improvement. That's almost a 20-point jump from the previous record, which was 42.2%, held by Sonnet 4, just 4 months ago.
Wow, 20 points in 4 months?
Yes. That tells you they've been hyper-focused on training for complex tool use. It's a massive leap in a very short time.
So the numbers look incredibly strong. Quantitative dominance, check. But then there's a qualitative side, the sort of vibe check from developers using it, and that suggests there's still a trade-off, right?
There always seems to be.
People are saying Sonnet 4.5 is way faster, much more steerable. I saw one review where it did a complex code review in like 2 minutes versus maybe 10 for GPT-5 codecs.
The speed difference is noticeable.
But the reviewer also said Sonnet missed a subtle, hard-to-find edge case in that review. And the slower, maybe more ponderous codex model actually caught it.
Right. And that really crystallizes the choice you have to make now. It's not about which model is universally best. It's about the profile. What do you need for this specific task?
Okay, spell that out.
Well, Sonnet 4.5 looks like it's optimized for velocity. It's your high-speed, responsive pair programmer, great for banging out features quickly, iterating fast.
The quick collaborator.
Exactly. Whereas GPT-5 codex, based on that feedback, sounds more like the, let's call it the deliberate deep thinker. Maybe the grumpy senior engineer type.
Okay.
Slower, yes, but potentially better for those really deep critical bug hunts where finding that one obscure edge case is absolutely non-negotiable.
So, as an engineering lead, you need to decide, do we need speed and momentum right now, or do we need absolute precision for stability?
Precisely. Define the need first, then pick the tool profile that matches.
That's a really vital distinction. Okay, now let's shift to what enables all this autonomous potential. The endurance factor. They're claiming Sonnet 4.5 can operate autonomously for 30 hours or more on one complex task.
Yeah, that number is pretty wild.
That's like 4 times longer than their previous top model. That kind of long-term focus, that stamina, that's different.
It's a huge leap in persistence.
And they gave this example, right? An agent taking a single prompt, something about adding tree-structured conversations to a command line tool, and it just went off and did it. Checked out the Git repo, ran tests, wrote the code, even handled a database migration, all autonomously, step after step.
Yeah, dozens of steps, unsupervised.
To pull that off, they must have cracked the context limit problem somehow, right? You can't hold 30 hours of work in a 200K window.
Exactly right. They couldn't just rely on making the context window infinitely large that's not physically practical or computationally feasible right now. So they tackled it differently. They introduced this new context management API. Think of it like an external organized memory system for the agent.
Okay, external memory, how does that work?
2 key parts. First, there's something called context editing. It's basically smart garbage collection for the context window. When a window gets full, it automatically figures out which old tool calls and results are probably stale, irrelevant now, and it removes them to make space.
Okay, pruning the old stuff.
Right. But the second part is, I think, much more critical, especially for enterprise use. It's the memory tool. This lets the model explicitly create, read, update, and delete files. But crucially, these files live in a memory directory that you, the developer, control on your infrastructure.
So the memory isn't just inside the model's black box anymore. It's external, file-based.
Exactly. And that is revolutionary because now that memory is auditable, it's scalable, it's persistent. For any company worried about security or compliance, this is massive. The agent's thoughts or intermediate work products aren't just ephemeral context. They're actual files you can see, manage, back up, put under version control.
That builds a huge amount of trust for long-running tasks. You can see the trail.
It's essential for trust in these long-running autonomous systems.
Okay, so while they were building this long-running capability, they found something unexpected. This internal feature they're calling context anxiety.
Yeah, isn't that fascinating? They say it's the first time they've observed a model seem actively aware of its own limitations, specifically its context window size and token budget.
Aware of its own resources. How does that manifest?
Well, as the model senses it's getting close to the context limit, it apparently starts to change its strategy proactively. It begins summarizing its previous steps more aggressively. It becomes more decisive, trying to rush towards completing the task before it runs out of space.
Trying to finish before the clock runs out, essentially?
Kind of, yeah. But the downside is, this can sometimes lead to what Anthropic calls undesirable shortcuts. It might skip steps or make assumptions it wouldn't otherwise make.
So it's like its internal resource management heuristics are kicking in maybe a bit too strongly, almost like panic mode.
That's a great way to think about it, actually. Forget psychology. It's about internal resource utilization heuristics under pressure. And this creates a whole new challenge for us, for engineers. Prompt design isn't just about telling the model what to do anymore.
You have to manage its anxiety.
Sort of. You might need to structure your prompts or use the memory tool in ways that reassure the agent about its available resources.
Yeah.
You might need to explicitly tell it, hey, you have plenty of external memory. Don't rush. Don't take shortcuts just because the context window feels tight.
Wow. Okay, that's a whole new level of interaction.
It really is. And strategically, you see how all these pieces fit together, right? The endurance, the hybrid engine, this new memory tool, it all launched alongside the rebranded Claude Agent SDK. They've got TypeScript and Python versions now. It's a very clear signal. Anthropic isn't just selling you access to a powerful model anymore. They're selling an integrated platform, a whole workflow for building agents.
A platform play, not just a model provider.
Exactly.
And they're making that platform shift incredibly attractive with the pricing. This is maybe the biggest surprise. Sonnet 4.5 delivers state-of-the-art performance, beating their own supposedly higher-end Opus 4.1 model on coding benchmarks. Yet they're offering it at the exact same price as the previous, less capable Sonnet model.
Yeah, it's aggressive.
It's $3 per $1 million input tokens, $15 per $1 million output tokens. Just to spell that out for you listening, that makes this new, better model 5 times cheaper than Opus 4.1, which was $15 input, $70 output.
5 times cheaper for arguably better performance, especially on coding.
What does that tell you? Strategically.
Well, connecting the dots, it's the clearest signal possible. Anthropic is basically commoditizing the core model itself.
Yeah.
They're making the price-performance ratio so good that adoption becomes almost a no-brainer for a huge range of tasks.
To get you onto the platform.
Exactly. The goal is to drive massive adoption into that higher-level ecosystem, the Agent SDK, the premium features in Claude Code, maybe getting companies onto dedicated higher-margin provision throughput contracts later.
So the model is the cheap entry point, the hook. The platform and services are where the real long-term value and profit lies for them.
That's how it looks. Commoditize the base layer, monetize the value add on top. Classic platform strategy.
Okay, makes sense. Now, quickly, for enterprises adopting this, the operational side, safety is huge for Anthropic. They mention it's deployed under their ASL3 safety framework. That's Anthropic Safety Level 3, their highest internal standard. And they say it shows fewer deceptive behaviors.
Which is good. Reliability and trustworthiness are paramount.
But they also acknowledge that these strong safety guardrails, especially around really high-risk stuff, they can lead to occasional false positives. They even have a term for it, the alignment tax.
Right. And the alignment tax isn't a bug, it's a feature, in a sense, or at least a conscious design choice. For any organization that's highly regulated or deeply concerned about security, finance, healthcare, critical infrastructure, this trade-off is necessary. It means you accept a small amount of operational friction, the model occasionally refusing to do something perfectly safe because you absolutely cannot tolerate the alternative.
Which is the false negative.
Exactly. A false negative where the model does perform a harmful action autonomously, that could be catastrophic.
Right.
A security breach, a safety incident, unacceptable.
So a false positive is annoying, maybe costs a bit of time. A false negative could be disastrous.
Precisely. So by designing the system to be slightly overcautious, to sometimes produce these low-cost false positives, they are explicitly minimizing the risk of high-consequence false negatives. It tailors the model's risk profile for cautious enterprise adoption.
Okay, that framing of the alignment tax makes sense for their target market. This has been a really deep dive into what feels like more than just a model update. It's an architectural shift, a strategic pivot. I think the main takeaway for you listening is that Sonnet 4.5 really pushes the conversation beyond the Copilot idea. It's reframing the human-AI relationship. not just assisting you line by line, but potentially orchestrating entire projects autonomously.
Absolutely. And that means the critical work for humans is shifting. It's less about the granular act of coding itself and much more about orchestration, supervision, defining the goals. And that demands new skills, right? You
Yeah.
need advanced prompt engineering, not just for clarity, but maybe to manage this weird context anxiety.
Yeah.
And you definitely need system architecture skills. How do you best use these new external file-based memory tools? How do you build agentic systems that are auditable, scalable, and reliable over these long 30-hour runs?
Which brings us to our final thought, something for you to really chew on. Anthropic mentioned that their Claude code environment now has a feature called checkpoints. The agent saves its work periodically. So you're not just coding alongside an AI anymore. You're effectively managing a digital engineer that can work for 30 hours straight, leaving behind this auditable trail of files in that memory directory. The question is, how do you need to restructure your workflow, your review processes, your entire approach to software development to effectively audit, supervise, and manage this new autonomous collaborator? That pull request checklist, it's probably about to get a whole lot more complex.